Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for this session will be college algebra, and this is now lesson number 89. We are almost done with college algebra. The title of the topic will be college algebra, lesson number 89, partial fraction, repeated quadratic factors. Okay, let's proceed. We are done with the past three cases of partial fraction. That is, the first case is if the denominator contains linear factors. Case number two is if the denominator contains repeated linear factors. Repeated. Third case is if the denominator contains quadratic factors only. And for tonight, I will be discussing the last case under partial fraction. That is if the denominator contains quadratic factors which are, what do you call this, repeated. Okay, let's try to bring out the form for case number 4. To be specific, and we don't want to overload our minds, we let n is equal to 2. Okay? So we simplify the writing of the form, okay? The given form is f1 of x over f2 of x, and this should be equal to a constant a times the quantity 2px plus q. The given quadratic factor is px squared plus qx plus r, okay, plus another constant b, all over same denominator quadratic factor, okay. The power of the first one is actually 1, okay, 1. So for n is equal to 2, there will be an additional 2 partial fraction. That is another constant c, same as this one, 2px plus q, all over the given quadratic equation. But instead of 1, this will now be 2, because the value of n is equal to 2, right? Plus another constant d, another partial fraction, all over the given quadratic equation raised to the second power. Okay? That is for n is equal to 2, there will be 4 partial fractions on the right. If n is equal to 3, there will be 6. Because we will add up another 2 constants, okay? But the resulting denominator will be the given quadratic to the third power, okay? So for n is equal to 2, there should be 4. This 1, 2, 3, 4. For n is equal to 3, there will be 6. And for n is equal to 4, there will be 8. But this is already the worst case scenario for a problem, okay, when solving integration using partial fraction. So we'll just place for the meantime n is equal to 2. At least we now know the format on how to bring out the equivalent partial fraction for n is equal to 3 and for n is equal to 4, etc. But just think of the, what they call this, expansion of n is equal to 2. Because if we know n is equal to 2, we could derive the value for n equal to 3 and n is equal to 4. Oh, that's the reason why I place n is equal to 2. It is easy to, what you call this, remember. If you remember n is equal to 2 for the expansion, you could remember n is equal to 3. Okay, let's try to bring out an example problem. One thing more, f2 of x is a quadratic factor. Px squared plus qx plus r, quantity squared, that is for n is equal to 2. If n is equal to 3, this will be 3, right? If n is equal to 4, this should be 4. But for the given form, I place n equal to 2, so this is quadratic, right? Okay, let's try to bring out an example problem. We are given the fraction x plus 2 all over x squared plus 1 quantity square. Okay? If we try to inspect the denominator, without the 2, it is a quadratic equation, right? That's why it is under what they call this quadratic factors, right? But there is 2 over here. And the problem is asking what will be the partial fraction equivalent of this. For n is equal to 2, there are 4 possible. 1, 2, 3, 4. The denominator of the first 2 factors are actually to the first power. And for the last 2 factors, the denominator is the second power. Right? So if we try to bring out the equivalent now of this one, I will try to rewrite the given expression. The right hand side will be a. Okay. I will tell you where I got this one. How come it is 2x? This is now a part of differential calculus. You take the derivative of x squared, that will be 2x. Okay? The derivative of 1 is actually plus 0. Or 2x plus 0 will just be simply 2x. Okay? So this is a part of what they call this differential calculus. I am telling you now the secret, right? This value 2x emanates from the differential of the given quadratic equation. Like this one here. Why this is 2px? Because if we try to take the derivative of px squared, it will be p times the derivative of x squared is actually 2x. Plus the derivative of qx will be q multiplied by 1. And the derivative of r is actually plus 0. So this will be 2px plus q. Okay, so this 2px plus q emanates from the so-called differential of the given quadratic equation, right? 2px plus q. Okay, they didn't teach you under algebra, but since I'm teaching differential calculus, I know where the secret is. So I'm telling you now where the secret is. To bring out this quantity here, just take the derivative of the given quadratic equation. So in here, if we try to take the derivative of x squared plus 1, it will just be simply 2x plus 0, or will just be simply 2x. Okay, so don't ask me where I got this 2x here. It is the first derivative of the given denominator. Okay. Let's continue. So following this form here, it will be b all over the quadratic factor. Since n is equal to 2, there will be 2 additional. So c, another constant c, times 2x over the given quadratic to the second power. Because this is to the first. This is to the first. So the next one will be the second power, right? Plus a constant d all over x squared plus 1 again to the second power. So this is 1 and 1, this is 2 and 2, because n is actually equal to 2. And if we try to simplify this one, the right hand side will just be simply x plus 2. Okay. For the second one, we try to multiply this by x squared plus 1 over x squared plus 1. Right? And so with this one, we multiply this by x squared plus 1 over x squared plus 1. For this one, as it is, because this is x squared plus 1 quantity square already. Because if we try to multiply the first two by the ratio x squared plus 1 by itself, x squared plus 1 times x squared plus 1, it is now the same as this one. So after multiplying the first two by this quantity here, the denominator on the right hand side will now all be x squared plus 1 quantity square. Okay? So the right hand side will just be simply x plus 2 now. This is 2ex. Okay, 2ex. 1 x squared plus 1 will remain on top, right? the one under the denominator will be multiplied with this one. So this is now times quantity x squared plus 1. The value b is the same. We maintain the value b times x squared plus 1. Okay? For this one, it will just be simply 2cx. Plus, for d, it will just be simply d. Okay? The given right hand side is under actually x squared plus 1 quantity squared. And for the left hand side, I expedite a little bit. X squared plus 1 quantity squared. Denominator, the summation of the individual numerators all over the common denominator. So actually this one here, cancel with it. So what remains? No more like this, right? No more like this. Okay, so it will just be simply that one. And if we try to expand this one, x plus 2 now, we expand, we distribute 2ax cubed plus 2ex plus bx squared plus b plus 2cx plus d. Then arranging the powers of x in the so-called descending order, x plus 2 should be equal to 2ax cubed. Quadratic will be next one, bx squared. Linear, next one will be 2ax plus 2cx. 2ax plus 2cx. The pure constant term is plus b. This is plus b. Plus b plus d. So this is actually the algebraic equation needed in the computation of the unknown constants a, b, c, d. There are actually unknown constants to get the equivalent partial fraction on the right. So equating coefficient of like terms, the highest power of x is actually 3, right? So we will start with x cubed. For the left hand side, there is no x cubed. We put it 0. For the right hand side, the coefficient of x cubed is actually 2a. So 0 is equal to 2a. Therefore, a now will be 0 over 2, or a will be 0. The next power of x less than x cubed is actually x squared. For the left hand side, there is no x squared, so the coefficient will be 0. For the right hand side, there is. This is an x squared, and the coefficient is actually b. Right? So 0 is equal to b, therefore b is equal to 0. Next power exponent of x is actually 1, so we equate all terms with x to the first power for both the left and right. For the left hand side, there is an x, right? Because the power of x is just simply x to the 1, right? So this is 1, right? And for the right hand side, there is an x over here, and there is an x over here. So we take the coefficient of the first one, that is 2a. Next one is 2c. Okay? So from here, we got an equation involving a and c, but we know a already. A is 0. So this will become 0. So c now will be equal to 1 divided by 2, or c is equal to 1 half. Right? Because this will now become 0. Because a is 0. So c will be 1 over 2, or c is equal to 1 half. The next power of x will be 0. So all terms that contains x to the 0. X to the 0 is actually a pure constant, right? For the left hand side, the pure constant is actually 2. It's 2, right? And for the right hand side, the pure constants are actually all those without x, x squared and x cubed. It will be b plus d. It is b plus d. But we know b already, right? To be 0. B is 0, so this is 0. So d now will be equal to 2. Okay, you got it, guys? Right. There are some values which are 0, so when we formulate an equation, we substitute those values so we could compute for the value of c and d. So the given function now, x plus 2 all over the quadratic equation x squared plus 1 quantity squared should be equal to, I will be following this. A is 0. Am I still on camera? Multiplied by 2x over x squared plus 1. The value of b is also 0, all over x squared plus 1. Plus the value of c. What is c? C is 1 half. This one half. All over x square plus 1 quantity square. What is the value of d? D is equal to 2. All over x square plus 1 quantity square. Actually, the first two are actually not existent. So the equivalent partial fraction of this will be 2 partial fraction 1 half over x square plus 1 quantity square plus 2 all over x square plus 1 quantity square. So if you are on the study of integral calculus, there will be an integral sign here and your professor will put a dx here. And what will be the integral of this one? So this should be equal to the integral of the right hand side because the function on the left is equivalent to the right, right? This is multiplied by dx. Okay. This is with the integral sign with multiplied by dx. So this is now easier to integrate than the left hand side. And so with this one. Right? It is still a complicated problem because we will use maybe trigonometric substitution here or algebraic substitution. Okay? But the equivalent of this one as 2 partial fraction will be 1 half over x square plus 1 quantity square plus 2 over x square plus 1 quantity square. I just put the dx to show that this problem might come out under the study of integral calculus. Okay? But the main topic for tonight is to take the equivalent partial fraction of this one. And our answer is actually this. Okay? 1 half over the given quadratic quantity square plus 2 over the given quadratic quantity square. That will be our final answer. So that's the way how to compute or the so-called equivalent partial fraction if the given denominator contains a quadratic equation, okay, which is repeated. The power 2 is repeated, right? If the value of n is equal to 3, it's still repeated. If the value of n is equal to 4, it's still repeated. But the least value of n for it to be repeated is actually n is equal to 2. Okay, that's it guys. This is Professor David G. De Los Reyes from Los Angeles. Good morning.